Welcome to our Scientastic class. I'm teacher Bradgeline, and I am here to help you understand how science works in everyday life. Are you ready to join me for today's lesson? Come on, let's learn together.
Hi, I'm Gabriel.
And I'm Elise.
Join us as we learn together.
To start with, I will show you a short video clips. What have you seen?
Ma'am, I saw a ball rolling, a man running, and a dog close the door.
Correct. Those are some daily activities we observe that involve motion. What do we mean when we say motion?
Motion is the change in position of an object in a given time.
Very good. Motion is caused by force. When we say force, this is a push or a pull upon an object resulting from the object interaction with another object.
Ma'am, just like the rolling ball, maybe someone push or kick it.
Yes, you're right. Today, class, we are going to learn about the laws of motion. Do you know who discovered the laws of motion?
Sir Isaac Newton.
Yes, Sir Isaac Newton was one of the most influential scientists of all time. He put forth the ideas of previous scientists, including Galileo and Aristotle. He was able to prove some ideas that had been theories in the past. Newton is also best known for his work in studying the gravity. He published his laws in 1687 in his work named Mathematical Principle of Natural Philosophy. Alright, let's try to figure out this one. What happens when we pull the cardboard with your hands? Yes, basically the coin moves with the cardboard. The frictional force acting between the coin and cardboard caused the coin to stay on top of the cardboard. How about when you quickly flip the cardboard with your finger?
When the coin was flipped quickly, the cardboard moved forward and the coin did not move with it. Instead, the coin dropped into the glass.
Correct. The coin did not move forward because of the tendency of the coin to stay at rest. In physics, this property is known as inertia. The first law of motion is inertia. Inertia states that an object at rest will stay at rest. An object in motion will stay in motion unless acted upon by an external net force. This rock is at rest and will continue to remain at rest. The soccer ball is in motion and tends to keep on moving unless there is external unbalanced force acted upon. Here, the unbalanced force is the soccer goal post. All objects resist changes to their state of motion. However, not all objects have the same inertia. Think of this way. There are two bags. One is larger and heavier than the other one. Which bag do you think is easier to move? Yes, the smaller one is easier to move because the larger bag's inertia is greater. Based on this example, you can infer that since the larger bag has more mass, it has more inertia. than the smaller bag with less mass. Therefore, mass is the measure of inertia. As the mass of an object increases, its ability to resist change in its state of motion also increases.
Why is it that when you kick a ball on the ground, it gradually slows down until it completely stops?
Very good question. Well, this is because of friction. Friction, the force acting on two objects sliding each other here on the planet which opposes motion. To better understand this, you must know what a net force is. Net force is the sum of all forces acting on an object. I have here an illustration that shows the different forces acting on the ball. One is the gravitational force, which is downward force, and the other one is the upward force called the normal force, which counteracts the gravitational force. Since these two are equal in magnitude and lie in the same line of action, but in opposite directions, the vertical net force is zero. In riding a vehicle, the law of inertia can also be observed. For instance, you are riding a fast-moving car when suddenly a dog crosses the street, causing the vehicle to accidentally stop moving. What do you think happened to you and the other passengers?
Ma'am, they will be thrown forward because their body is in motion with the vehicle.
Very good. Since you cannot stop yourself from moving, you are required to wear a seatbelt to counteract your body's inertia. This is all for today, class. I hope you learned something. See you on our next episode. Bye!